Okay, good day everyone, and welcome to our webinar, Accelerate Transformation with Test Automation. I'm Stephanie Wandale, and I'll be your moderator today. Today we will be covering these key topics. Why is testing important? What is testing? People, infrastructure, and process, and how testing accelerates transformation. Before we get started, for those of you who don't know Delaplex or cycle automation, I wanted to take a minute to tell you a little bit about who we are and what we do. With Delaplex is a global custom software development and business solutions provider. Since 2008, we've been focusing on enabling business growth through scaling development capabilities. Cycle Automation is a growing team focused on modernizing enterprise solution deployment by lowering risk, leveraging enterprise test automation. I'd like to introduce today's speakers, Josh Owen and Bruce Howe. Josh Owen is co-founder of Cycle Automations and Chief Executive Officer. Prior to this role, Josh led the development of the Cycle product from its idea phase to the valuable continuous testing platform it is today. With over 15 years of experience deploying Blue Yonder solutions across various industry verticals, Josh is dedicated to modernizing enterprise solution deployment and helping companies focus on business growth rather than worrying about business risk. Bruce has extensive experience working across EMEA for the last 20 years in roles covering both sales, consulting for organizations such as Blue Yonder, NTT, Data, and SAP. His most recent role was leading Blue Yonder's retail practice across Europe, Middle East, and Africa, delivering both supply chain and planning and execution solutions for a range of large retail organizations. And with that, I will pass it to Josh. Take it away, Josh.
Thanks so much, Stephanie. And thanks to everyone who could join us today. We'll touch on a few dense topics, but keep most of the conversation relatively high level as introductions. And if there are particular topics that you find interesting, please let us know and we can dive in a little bit deeper, possibly on a future webinar. So let's start by talking about why testing is important and why we should all be thinking about test automation. Software testing, and in particular, the automation of software testing or test automation, has become a great topic of interest in recent years. Today, we'll introduce you to just a few reasons why you should be thinking about how your organization should be leveraging automation for solution quality. So, through a confluence of recent events, we're seeing many threads come together across our industry, leading us in a common direction. And these common threads underscore the importance of an automated quality solution. First, let's take a look at consumer expectations. Consumer expectations for same or even next day delivery and this sort of instant gratification have become industry standard, and supply chain application development velocity is increasing rapidly to keep up with this demand. Lofty expectations from consumers create strain and pressure on a supply chain that's already struggling to keep pace being set by giants like Amazon. Customers want instant gratification, a curated experience, and we must be more responsive, flexible, and proactive along the entire supply chain to deliver better customer experience, because today's consumer cares more about experience than they ever have, and we simply can't afford to give them a bad one. Related, we're seeing a frequency in which enterprise applications are changing increase and associated deployment rates increasing in kind. This is in close correlation with the adoption of these agile philosophies. Simply put, to continue meeting consumer expectations, the systems that support our businesses must change more rapidly than ever before. And the implementation and deployment practices that support these packaged software solutions has just simply not matured at a rate reasonable to support the speed at which deployment cycles are increasing. Many of our customers are only upgrading their enterprise solutions every 2 to 3, if not 5 to 7 years, even though the OEMs of the software solutions that they use to drive their business are producing incremental value and hot fixes and upgrades as often as 2 weeks. And this basically creates a bottleneck in delivering value to the customer. As our industry focuses on a move to the cloud and true SaaS readiness, These associated agile initiatives like DevOps, continuous integration, continuous delivery, and today, continuous testing are critical to ensure packaged software deployment teams are delivering high value, on-time solutions. And finally, the COVID-19 pandemic has exposed many challenges related to the current state of the global supply chain. Many core practices that our industry has embraced are being reevaluated. Just-in-time inventory strategies in the quest for leanness, cost cutting, these things have adversely affected many organizations over the past 12 to 14 months. And organizations simply didn't have processes in place allowing them to react quickly enough. So what's next, right? How do organizations make the right choices today for the future, for the next pandemic or the next Suez Canal, the next time that we simply need to adjust our processes quickly? The truth is there likely isn't one single answer, and that likely the best approach is to reintroduce some level of slack into our supply chains, eliminate some level of rigidity while continuing to operate reasonably lean. We don't have all the answers, but more than ever, it's clear that supply chains need flexibility. Test automation is at the foundation of these agile initiatives. And organizations built on agile practices who have the ability to flex, to ultimately accelerate change, these will be the ones who thrive in today's environment. Okay. So we've talked a little bit about why test automation is important, and we looked at this sort of confluence of events that underscore the importance of it. So let's take a look at what, and quickly define, what is automated testing. So my friend, a good friend of mine, who's an expert in this space, Andy Knight, defines test automation as leveraging modern software solutions to automate the validating of goodness and the identifying of badness in software solutions, product code, and features for the purposes of enforcing high quality standards. And you might be thinking, but we're a supply chain organization, not a software company. So why is it up to me to test my software? Isn't that the responsibility of the developer or the company building the platform? And I would challenge that line of thinking. I would say today you are a software company. So are we. We all are. Our building blocks are just larger. And rather than focusing on a particular piece of code or a specific feature or function, our solutions are built on packaged enterprise software solutions integrated together to satisfy and meet our critical business needs. And these enterprise solutions that are created through a mesh of existing software applications, these need testing as well. In fact, we face the same challenges as organizations who are building software from the ground up, things like miscommunication, software bugs, misaligned expectations, but we simply have to solve these challenges in a different context. And this requires different tooling and ultimately different expertise. So let's take a bit of a deeper dive. There are essentially three fundamental categories to software testing. There's functional, which is, does this solution work correctly? There's performance, which is, does the solution work within the desired system metrics? And there's experimental, which states, does the solution work with improved features and metrics after some system change? Today, we'll talk in more detail about functional testing while touching on performance testing. And you can jump to the next slide, Stephanie. Yeah, okay. So functional tests determine if the solution works correctly and should deterministically result in either a pass or a fail that validates that expectation. If the functionality works correctly, it means that the mutually agreed upon results have been achieved. That is, that the business requirements have been met, the software or solution specifications have been satisfied, and that ultimately, and arguably most importantly, this solution meets the user expectations and provides a good user experience. So you might have seen this before, but if not, let me introduce to you the testing pyramid. It's an industry standard guideline for functional test case strategy. The testing pyramid is intended to show visually the ideal focus, testing type, and size of a comprehensive testing strategy. Each layer helps us understand as a guideline how we should approach our testing strategy. And I'd like to present it in a new context where we're focused on package solutions, and in particular, the goal of risk mitigation across our core business functions. So if you look at the bottom layer, the unit tests, these are the smaller tests, generally smaller in size, generally smaller in cost to development, but they tend to focus on incremental validations. In the enterprise, we should use these with care and should be focusing more on the higher value end-to-end tests. We on some level should take for granted that the solutions we have chosen run our business, that these work as designed. What we must validate, however, is that they satisfy our critical business needs. The middle layer, the integration tests, this is where we focus on where two different systems intersect. Often different applications like a parcel system or a transportation management or a host system, and how these various systems work together. And finally, at the top, we have system tests or end-to-end tests just under our unit testing there. And these tests cover a path through the system, and they're normally black box tests, meaning that they're ran the way an end user would experience the solution. And this is where we should spend the majority of our time and effort, as these tests often provide the highest level of risk mitigation. Our organizations are powered by a network of complex interfacing packaged software solutions, and they make up the backbone of our business. So ensuring that changes to these individual solutions do not interfere with our ability to work should be our focus. And our tests should be automated when they give us a positive return on investment. Okay, so let's take a quick look at performance testing. Once we're satisfied with our functional tests, that we've ultimately automated our critical business processes, and that the solution reliably meets our business needs, we can now focus on performance testing. Performance testing alone warrants an entire series of webinars, so today we'll keep it brief. Performance testing determines if the solution performs well and within our desired system metrics. So good performance means minimal impact to these primary software performance metrics: processor usage, memory usage, response time, and throughput. And for the supply chain, we care about performance in a variety of situations, everything from managing peak season volumes to concurrency challenges when we shift work from one functional area to another. What would happen if we had 60 people picking instead of 20? Could the system even handle that? Will our system function in an ideal manner if we serialize our inventory? What happens if we need to double up staff today on replenishments because we're expecting higher picking volumes tomorrow? A good performance testing strategy will allow us to simulate all of these what-if scenarios and ensure that we're ready for whatever our business asks of us. Performance testing is critical to our ability to make the right choices today for our business. Now, finally, once we have constructed valuable functional and performance testing strategies, we can begin to shift how we view and think about testing. I think traditionally, organizations have viewed testing as a defensive strategy, right? That is, that it's primarily intended to protect against system changes that result in regressions. But simply put, we're trying to prevent bugs from making it into production. I would say that with a solid functional and performance testing strategy, we can actually shift from a defensive strategy to an offensive testing position. And not only will automated testing ensure that the days and weeks of hundreds of hours of fixing issues in productions be a thing of the past, but it gives our teams the freedom to innovate and the freedom to focus on business growth rather than business risk, and the ability to stay current on modern technologies without fear of introducing change. Because the ability to change quickly, to adapt, innovate, and be resilient is no longer a luxury, it's simply a requirement. And organizations focused on these defensive strategies rather than offensive strategies won't continue to win. And so with that, I'd like to pass it to Bruce, who's going to talk to us about how people play a role in our testing strategy.
Brilliant. Thanks, Josh. And we can seamlessly transition from North Carolina to London. And, you know, that's the world we live in these days, of great collaborative access for everyone. So, you know, the title of the webinar is How to Accelerate Transformation. And what Josh has talked about is actually testing being a key lever of transformation. And before we step into the next slide, just remember your Q&A button at the bottom. So, Stephanie, if we move on to the next slide, please. So we've looked at effectively the overall transformation roadmap, and what constitutes essentially a testing framework. And what we have is what we've worked on between Delaplex and Cycle is a series of activities that we've brought together as a package of knowledge, IP, artifacts, and tools that will help guide organizations through this transformation and help the acceleration. So the top part of it, we talk about the strategy, which is essentially the what, the when, the how, the who, bringing it together. And you take it down to a more granular level and start building up your plans. So you're taking stuff out about the overall project timeline, start to developing tasks, and then you're executing tasks, and then you're accelerating tasks through automation. What we acknowledged when we started looking at this and the best practice we work with within supply chain, but also within other industries like medical imaging industries and other industries like that, is we looked at there are foundation levels. There's people that are really critical in this. There's data, and there's how do you measure and continuously improve testing over time. So the reporting structures and making sure all of this works within a governance framework of your program, of your transformation. So it's not something that sits on the side as a silo. It has to embed itself into your transformation program or even your project program. They need different elements of this. So we're going to look at a few things this afternoon. I'm on afternoon. We're going to look at a few things. We're going to look at people. We're going to look at some of the processes, and we're going to flip back and look at automation as well in terms of having another dig at automation. But our first stopping point is people. So where does testing start? Well, it starts with people. If we think about what happens typically in terms of how testing is addressed in that ramp-up period before a project starts, the focus naturally when you're engaging with your vendors or your own internal development teams is actually what is the business going to get out of this? We're going to focus typically on features and functionality. What is the value to the customer that we're creating? Why are we actually doing this program? And often, that structure doesn't really address what needs to be done from a testing perspective. And, if I live in the world of a vendor, testing is difficult and you tend to pass it back to the client. So the client or the client's system integrator partner or the partners they have in place, you actually gently get them to accept responsibility. Effectively, you understand your technology better than we do. You understand your data and your processes. So the client will actually generally often accept those arguments, and they're really solid arguments. But effectively, they're going to go, okay, I'll take on the responsibility of testing, knowing that the software I'm procuring is largely going to work. The unit testing that goes on it and the factory testing that goes in OEMs these days is of very high quality. And what doesn't work is generally fixed pretty quickly under warranty and support and maintenance agreements. So the testing work is then silently moved into the program from the program planning perspective. The timelines and effort are not particularly well estimated. So the vendor and the business IT team are normally pretty good at estimating what they need as people resources to do tasks, but it's effectively the business involvement is poorly estimated, and the impact that it has on the business is often not fully understood. And it's just a task on a project plan. And it normally sits, to be fair, at the end of a project plan. So from a people perspective, what happens when you step inside the next element of the testing of the testing process, Steph? And the typical testing team look like. So if we sort of assume that there's people in the vendor, the solution principals in the vendor, they do a bit of the testing. You have IT specialists that will effectively look at some of the technical sides of testing, but the testing generally falls to the business users, and their responsibility spread out throughout the project. And of course, they have their day jobs. It's very rarely that you see people fully seconded from their day jobs to projects. Obviously, in large-scale transformation, this happens, but often they still have commitments. And it's often done in a unit function. So they'll work with, if they're working in an agile manner, they'll work with the sprints and they'll look at effectively the test that proves the software works. So here's my idea, this is how it works. So it proves the happy path. It proves when everything's in place, it works. And then when they get into their testing, what often happens is that as soon as they find a defect, it often stops testing. So they'll allocate time to do testing. They'll come to it, it's on the critical path for go live, and they'll hit defects, and they'll hit 2 or 3 defects. And the nature of these defects varies. They're often not software defects, but they're build defects, they're configuration defects, or when the end data is passed through end to end, actually the data just looks wrong. It doesn't represent what I do in the business. The order volumes are too high, the lead times are incorrect. It's assigned to the wrong people with the wrong skills. And those are data things, but actually they're often mistaken as bugs and defects. So it's not a simple task. And what often happens when you're, again, working with people who are the business experts, they focus on the happy path. But when you're investing in large-scale transformation programs, it's because you've got very complex scenarios to solve. So if you talk about a replenishment or a warehouse scenario, it's not often a yes or no answer. It's actually dependent on expiry dates. It's dependent on when is the stock available, is it allocated to other customers? So the happy path is not often that happy. It's not that straightforward because you're going to be testing lots and lots of scenarios. So what happens to that team? Honestly, they get worn out and they get frustrated by effectively, they keep on getting work that's drip fed into them instead of effectively fully understood up front. Instead, let's look at what we can do from supporting that team. So one of the things that you would want to do is actually, how do you augment that team? And this isn't replace that team, it's about supporting them. And we'll give you a couple of examples. So when you go through that example of building a solution, I'm talking about a fulfillment solution or something like that, you've got the planning manager and you've got the solution architect designing something. What you want to be able to do is actually at that point say, what does the happy path look like? If everything works, what is the result I'm going to expect? I'm going to expect an order to be placed for picking to meet an order from a DC to a store. But there are many things that will change the variation of that test case and that test result. So what your test specialist will be doing is supporting your SME that says, actually, we're going to write a lot of test use cases. There isn't just one, there isn't just the happy path. There's actually a lot of nested paths that can become as outcomes, which are all correct outcomes. But if you only test on the happy path, it actually fails the scenario. So getting people who are specialists in writing test case, who understand test case results, and then map them back to the traceability matrix, the actual functional requirement that's spoken in English language by the business users, and you're tying it back. So you always have that mapping. So one of the things that we're really strong on is actually understanding what test specialists look like, understanding how you can support your generalists, and I hope that's not an unkind way of describing them, but your business expert users who add value by making good business decisions. How do you support them with specialists, people who write test cases, who know the techniques, who can develop traceability matrix and go back to the core business requirements? So, when we talk about our framework, people are one of the foundations. So whether it's people who are specialists in what we've described in terms of writing test cases, but we've got specialists from an automation perspective, from security, for performance. And actually, you don't need them full time. It's actually making sure you have access to people that can exist in your own organization, but these are, often expensive people to resource and have on the bench, so to speak. So we've had a little look at people. I'm going to ask Josh now to pick up and talk a little bit now about what does an automation framework look like before we go back and look at some processes. So Josh.
Thanks, Bruce. Okay, so Bruce just walked us through the people role in testing and why it's often helpful to have access to specialists to supplement our team. And this will actually help us shift testing left in the project lifecycle, right? Create a faster feedback loop where we can test early and often. And this is a critical point, right? Automation within our testing strategy isn't necessarily about bug count, but rather finding these issues earlier in the project lifecycle so that we can remedy the issue early on and eliminate the chances of those issues making it into production. And like any automation, it's accomplished by a particular set of tools and technologies. So ultimately, test automation is accomplished by combining a suite of modern technologies that are integrated together to automate and orchestrate software testing at scale without the need for human intervention. These technologies are critical for us to eliminate the testing bottleneck and create an ecosystem where we can get faster feedback, faster validation, and ultimately a reduced time to value. No matter how well-intentioned a team is, achieving true test coverage and desired quality is simply not achievable without these tools. So there are a plethora of tools today that can be selected and integrated to accomplish a variety of automation goals. So for today, let's talk about technology that's best suited to achieve the goals of increasing development velocity, maximizing productivity, and achieving testing sustainability. So in the enterprise, most businesses are moving away from homegrown solutions, right? And they're leveraging these best of breed applications. And so for this problem, we need a tool set that has broad application, one that can span teams and technologies. And ultimately, we want to construct what is referred to as a pipeline. The first puzzle piece in that pipeline is our automation framework. This framework is the first decision that we must make. What tool are we actually using to articulate our automated test cases? Especially in the enterprise, we need a framework that works across technologies. And so we need to choose a framework that works in various technologies that powers our business. Ideally, we can use the same framework, everything from our legacy systems to our modern systems, and one that can actually grow with us as these solutions evolve. Often testing issues are rooted in early miscommunications, and so we need to focus on executable specifications, as Bruce was saying, constructed earlier in the pipeline. This will better align our business expectations early and often. And so we want a framework that provides inherent traceability, right, to the underlying business requirement being tested. More value is overlaid from the humans to the technology when the tests provide context for the business scenario being tested. And ultimately, this decision can make or break a testing project. The best framework is one that will fit into your existing workflow, streamline how your teams work, and ultimately provide alignment without extra work being tacked on. All right. The next puzzle in our automation landscape, or rather puzzle piece, is revision control. Revision control provides revision-based tracking for our target application or our system under test. It does things like managing configuration, source, rollouts, hotfixes, etc. It's a convenient home for our projects, especially when they have parallel work streams. It allows for branching, and this supports multiple variations on a core solution. And ultimately, our pipelines can follow these various branches. And these branches might represent various deployment permutations. In our case, maybe different facility types, right? And within our ecosystem, for example, maybe some of you have facilities which are manufacturing facilities, and some are fulfillment facilities. And these different facilities may require different core configurations. And this can all be managed in an organized manner in our revision control solution. Our next puzzle piece is the automation server. This is the primary engine in our pipeline. The automation server is our console, our mission control, and it's the central point of integration. A strong server, an automation server, will integrate with our task management solutions, doing things like sending us alerts via email or chat, and ultimately it will pull the tests and the configuration from our revision control and orchestrate the tests across the platform, allowing us to view and interact with jobs, results, and reports all in one place. Next, we have containers. Containerization is a form of operating system virtualization through which applications are run in an isolated space called a container, all using the same shared operating system. A container is essentially a fully packaged and portable computing environment which dramatically simplifies testing infrastructure. It helps us minimize OS licensing, componentize our application stack, and even does things like spinning up disposable test agents and instances of our system under test. And this allows for repeatable deployment and testing. Your containers are managed in what's called a cluster management solution. The cluster management solution is the management of our containers. They manage the startup, the execution, the teardown of these containers, and ultimately create scalable clusters, allowing for infinite possibilities. Imagine simulating a full day's warehousing staff at peak volumes, or even twice peak volumes or more with minimal dedicated infrastructure to manage. Containers allow us to do this infinitely without needing dedicated machines, licensing, or even maintenance for these particular systems. And finally, the last puzzle piece we have in our technology landscape is compute. Ultimately, all these solutions need to live somewhere and these tests need to be ran somewhere. And there's a lot of options here. We can do physical or virtual, private or public cloud, out of the box solutions, or even commercial things like hypervisors or infrastructure as service providers, things like Google Cloud or Microsoft Azure or Amazon. There is a plethora of options for compute, and we just need to focus on one that fits our particular need. And so depending on our expertise, our budgets, or our organization's policies, these pipeline solutions can be chosen to fit our particular needs. And with a pipeline, we can have our tests running regularly, not daily, because ultimately, what's the point of test automation if it's not running on a regular basis? So wrapping up the technology landscape, choosing the right technology will ultimately help us construct a pipeline that satisfies those goals. Today, we talked about particular goals of increasing deployment velocity, which is achieving regular iterative deployment with higher levels of quality, maximizing productivity, which is our ability to make the right choices now, faster than we ever have before, and ultimately achieving testing sustainability, which is reducing the work and the stress on our staff to free up these talented folks to be forward thinking and think about our next business challenge and not be spending their time too much doing data setup or repetitive testing. So we've talked a little bit about the technology, we talked about the people, and now I want to pass it back to Bruce, and Bruce is going to bring it all together with the role of process in our automation journey.
Brilliant. Thanks, Josh. Hey, so we're going to sort of wrap up the session today with the last piece before we get to any Q&A and closing thoughts around some of the process elements. The process that sits across the strategy, the plans, the execution, and then accelerated process through automation. And we're going to look at just one element of process. So you can bring in, when you're working with a partner, you can bring in all the techniques, best practice, artifacts around bringing this all together. And we're going to bring in, sort of look at one question, which is actually, what do we test? Which is like, we've talked that testing is important, it's critical, it's a key element, but what exactly are we testing? Now, I've had the opportunity to sit on steering boards of a number of programs. And you often hear in these early meetings, we've taken the handover from the sales organizations, the knowledge transfers happen, and we'd have that testing around, and we'd have individuals saying things like, we're going to test everything. This solution is going to be 100% zero defects. There'll be no bugs. And then they'll concede a little bit, and then they'll start categorizing bugs. And then they'll go down because they've understood the path that actually there's a potential to automate it so they don't need their business users. And so we're going to automate everything. So you have this sort of culture that says, actually, we're going to test an awful lot. We're going to test everything. We can't have too many like Sev1, Sev2 defects before we go live, all of which are valid statements. But we're living in a world that we're trying to maintain velocity and speed. We're going to try and do agile delivery and deliver at pace to consumers. So you can't take that approach where we're effectively trying to get everything perfect. So unless you have unlimited budget, unlimited resources, time everywhere, these goals aren't feasible. So one of the things that is a really well structured approach is actually risk-based testing. So delivering a test strategy that actually gives you coverage. So you would typically maybe have 500, 1,000, 1,500 tests to deal with, but actually only 500 of them make a difference. And we're going to focus our effort on delivering those. I think one of the best ways for us to just talk this through is to give an example. And it's a really simple example. It's actually, we'll go back to our favorite place, the warehouse. We've recognized there's a lot of demand coming in. There's a lot of orders coming in. We're going to extend the shift at the weekend. Supervisors speak to the pickers, and they're saying, guys, we need you to extend your shift from 7 hours to 10 hours. Just log on the ESS portal, extend your shift. It's a normal transaction, most normal thing in the world. But actually, if we look at this from a perspective, actually, what does it mean? You've got different employees. They're at different ages. they've got different skills, they've got different length of employment. They've already worked a certain amount of hours this month already, and they've got different pay grades. So you can actually have multiple results that are all correct. So how do you pass or fail the criteria when you test this? Because you can have a straight 7-hour to 10-hour extension, but you've got a guy who's been working for you for 20 years or 15 years. He's on an old contract. He's got a great labor contract. So when he extends from 7 hours to 10 hours, the result should be it's an 8 hours plus a 2-hour overtime plus an additional 15-minute break. Okay, so that's an outcome. The guy who's on 0 hour, the contract worker who you've just employed, he's just happy for the hours and the rate. So he gets no overtime, he doesn't get any penalty rates, gets no break, he's just going to work the extra 3 hours on his shift. And you have the guys who are fixed salary employees. They're going to get 8 hours, they're going to get 2 hours, and they're effectively going to get a 2 hours overtime. So you've got something that's a very simple requirement, but actually to ensure that you're going to test this across your user base, you've got to effectively look at more than one test. It's only one test case, but we've got a number of outcomes. So Stephanie, we'll now look at risk-based testing. So when you start off with your testing program, and at the beginning of it is actually a very easy thing to put in place, because when you're doing the requirements gathering and when you're doing effectively the design, if you've got someone who understands risk-based testing, working with your solution architect and your business user, you can actually have a very quick conversation, which is, how complex is this requirement? Is this something we're going to need to test? What is its impact of failure on the user? How often is this likely to fail? Is this part of code that's really complicated and the software often breaks? Is it business critical? And so those are examples, but your scoring mechanism, whether it's high or low, yes or no, 1 to 10, 1 to 5, you can build up a matrix that says, actually, I've got to make some criteria that's going to effectively weight these requirements. Because if I have to test, in this case, for a very simple one, we've got 4 outcomes, but you can quite often see where you've got very complex systems with deep embedded heuristics, rules-based systems, that you can effectively have dozens of different outcomes. And you don't want to get in this situation that every time you take a release or an upgrade or a hot fix, you've got to go back and regression test these outcomes. But you need to cover with a certain level of certainty, actually, what am I going to test? So when you do that and you look at the scoring mechanism that you get in this scenario, so we've just scored this on the next slide. What you do is you're able to, do the test complexity. Some are quite simple, some are actually a little bit more complex. The impact of failure, everyone knows with timesheets and overtime payment, that spreads very quickly if that's done incorrectly. But effectively, it's for your core employees. It's less pain for you if your contract workers get it. Past likelihood of failure, and is it a business critical issue? Then you get a scoring mechanism that says if you're going to test one scenario, you test one with the highest one, or you effectively set your boundaries. So you have your, whether it's 1,000 or 1,500 or 10,000, you can effectively look at the amount of scenarios you get and effectively test to that profile. So it allows you to, by embedding this technique into the process of actually capturing user requirements, attaching it to a traceability matrix, and then effectively looking at risk-based testing, allows you to start prioritizing in a very smart way, but by something that's very accessible to your project teams, how you're going to go about testing. Of course, there's flexibility. If you've got must-have, can't-fail processes, doesn't matter what the score is, you test them. But it effectively provides a great framework for you to go, exactly what do we test? And it actually allows you to communicate that back and forward to the business. I think on that, Steph, as we move on to the last slide, we've effectively looked at our framework. We've spent a bit of time looking at automation. We've highlighted a couple of things like the role of people and one technique in terms of a process. We haven't touched test data management, continuous improvement, continuous development, and reporting. So I'll now pause for a second and see if we've got any questions, or then we can just move to closing thoughts. So I'll maybe pitch on this one first, ask Josh for some input, and then we'll look at the Q&A that's actually come in then. So lessons learned in terms of, we're in the world of actually made the justification around testing being a critical part of transformation. So from my perspective, from the people and process, this is all about starting early. It's using specialists and developing a strategy so you can figure out, what are the specialists and timing that you need. And that testing strategy sits very much in part of that project preparation. It's not something that can be done when you're into sprints and things like that, because you're already generating test outcomes then. It actually has to be front and center in that project preparation phase. So big message, start early. And Josh.
Yeah, thanks, Bruce. I think you nailed it. I think to touch on these last couple of bullet points here, ultimately it's about creating artifacts that provide long-term ongoing value, right? If we use a solution, if we use an approach that provides sort of a prescriptive shift left approach where we can actually articulate business requirements as specifications, then our artifacts actually provide a longer-term inherent value. So they don't just provide value for testing, but they provide this sort of inherent value around communication and alignment to making sure that everyone understands what it is these solutions are being designed to satisfy up front, which provides an inordinate amount of value. And of course, leaning back on the do not automate everything paradigm, right? You've talked about this a couple of times. It's sort of the natural human tendency. If I have this really fun automation thing, let's just automate everything. But as Bruce pointed out, that basically takes, infinite resources because at the end of the day, there's a cost to everything. So we need to be prudent in how we approach what should be automated. And the best way to do that is with a risk-based strategy, one that actually measures where do you get the most bang for your buck and ultimately shows us very definitively that this investment is going to result in an ROI. Automating everything is just simply not the goal. Okay, and so I think with that, Stephanie, we can jump to any questions that came in.
Excellent. So I am going to pass those to Hillary. And Hillary, if we have any questions, I will let us know.
Hello, everyone. Yes, we have a couple questions. We'll go into the first one. Would you apply the same methodology to all types of application software, or does some suit it better than others?
I think no matter what our system under test is, the general approach is going to start from the same set of principles, right? There's a framework that helps us identify high-profile critical business processes like Bruce talked about. And this risk-based coverage is going to help align expectations with stakeholders earlier in the project lifecycle, focusing on value. What we want to do there is make sure that we're minimizing maintenance while focusing on risk mitigation. So these principles, this framework, that's going to be common. Now, the particular sort of like smaller decisions that we have to make, these more granular choices around how are we generating data, how do we load the data into the system, or do we use a programmatic approach versus drive the application from an end user perspective? Some of those decisions are going to be different based on the technology being tested and what the ultimate goals of the testing project are. But the sort of framework, the approach, the way that we measure the value, that's going to be fairly common. So the implementation of a particular test might be unique, but the overall approach is probably going to be fairly common across technologies and systems.
How do organizations usually deal with automated testing? Do they work on it internally or have a partner?
So what do organizations typically do with automated testing? Well, I'll give you the consultant's answer, which is it all depends. There isn't an answer. Organizations, there will normally be some skills in organizations, some skills and some tools that they're familiar with. So the answer is it's always a bit of both. So there'll be some stuff they're very familiar with, and there'll be tools and processes. And actually, Josh gave a really sort of thorough definition of what automation is. But again, most organizations have a very different structure around what automations is. So customers tend to bring some skills, some elements, and they'll normally have solution champions, or they'll have a solution lead that wants to use it. One of the dangers you see is that they'll try and use the wrong tool for a certain type of testing. So it's worth from a project outset, it's just to have a look at is the range of tools we've got appropriate, and are they actually going to deliver the type of testing that we're going to need. So, we go back to the framework, which is actually asking the questions about what are we testing, when are we testing, how are we testing? And actually, you still have to ask that question. So even though you have experience around an automation tool, it's always only ever going to be part of the puzzle. So that's my thought on that. Josh, anything else on that?
No, I think you nailed it. I think there are some organizations who have the capacity and the right tool sets and expertise internally to tackle this. I think there are many that aren't. I think it depends on the system under test, the ultimate goal. I think more often than not, having an expert come in and at least get you started on the right foot is going to be the best bet for most organizations.
Thank you to everybody for joining us. Thanks to Josh. Thanks to Bruce for speaking today and teaching. And thank you to our attendees. With that, I hope this was a valuable use of everybody's time, and have a wonderful rest of your day. Have a good one. Bye-bye.